Hello, and welcome to the fourth in a series of films about the standard level organic chemistry topic. Here we're going to be looking at alkenes. These are the second of the homologous series that we're going to look at after alkanes. So that's not a typo. This is actually a different homologous series, and we're going to see what main features it has, and also the fact that it uses the same kind of prefix system as the alkanes naming system used, and we're going to hopefully be able to draw and name the first 6 of this homologous series. Okay, first of all, let's look at what features these molecules have that enable them to be part of this family, this homologous series. Okay, that once again, like alkanes, they are hydrocarbons. They're made of only carbon and hydrogen, but in this case, the carbon atoms have one or more multiple bonds. That is to say, they might have double bonds in fact, alkenes have at least one double bond in their structure. Okay, there are things called triple bonds, right, but they're reserved for a homologous series called alkynes, and we don't really need to know very much about them, so I'm going to steer clear of them, and we're just going to deal with double bonds in alkenes. Okay, now we say that these molecules are unsaturated. Why do we say that? Well, because if I drew ethene, for example, this is the smallest alkene, okay, without taking any atoms out of this molecule, I could put some more in, because if I broke this double bond, for example, but left the 2 carbons attached, then I'd have a spare bond to each carbon. So in other words, the carbons have the capacity to bond to more atoms without removing any atoms from the molecule first. Okay, so this means that the alkenes are actually quite reactive, as we'll see later. Okay, so they're unsaturated molecules, unlike the alkanes, which were saturated, and these have the general formula CnH2n. And I suppose that might be quite intuitive, really, if we're happy about the fact that alkanes were CnH2n plus 2, because if that was propane, and that's an alkane, and I put a double bond in between 2 of the carbons, then suddenly these 2 bonds, for example, wouldn't be able to exist, because this carbon can only form 4 bonds and that carbon can only form 4 bonds. So instead of being CnH2n plus 2, like the alkanes, as soon as we put a double bond in, they become CnH2n. And we only need to deal with alkenes that have 1 double bond in them. Could have more than 1. Okay, here are the first 6. Well, really, it's the first 5, because the first one doesn't exist, right? The prefixes are the same as before, so I've put in capitals the suffix, the ending of the names. So because these are alkenes, they all end in -ene, whereas the alkanes ended in -ane. Once again, you can see that they've got the first 6 prefixes: meth, eth, prop, but, pent, and hex. Okay, and these formulas, which follow the rule of CnH2n, so the number of hydrogens is twice as large as the number of carbons. Why is there no methane? Well, because you have to have at least 1 carbon-carbon double bond, and if you have 1 carbon atom, because that's what meth means, then you can't possibly have a carbon-carbon double bond, can you? Anyway, so ignoring methane, which doesn't exist, let's start off by drawing ethene. So that would have 2 carbons and a double bond, and then hydrogens filling all the other spaces. Okay, if I wanted to attach another carbon to the chain, I'd have to use up one of these bonds, so that would be CH3 there. Okay, now I'm getting lazy again and not drawing all the hydrogens because I want to save time, but bad habit, don't do it. Okay, and then so that would be C3H6. Hopefully you can satisfy yourself that there are 6 hydrogens there. Put another carbon on, so extend the chain by another CH2. Okay, and it's become C4H8, C5H10, and C6H12. Okay, once again, there may be people thinking, well, hang on a minute, this isn't the only way I can draw C6H, did I just say C6H10 before? C6H12, anyway. There are other ways of drawing it, but we'll look into that later when we start talking about isomers. Okay, so there are different places I could put this double bond, but that's not what we're worried about for here. We're really just thinking about how we use this prefix and suffix system to name them. Okay, so hopefully, once again, you now know the features this family has. Okay, so they're alkenes, not alkanes this time, and you know how they're different. You know how they're similar too, and you know how we're using that same system of naming as before, and you can draw and name the first 6, or really the first 5. Okay, as usual, if you've got any questions or comments, I'd love it if you posted something on YouTube, because then other people can see your questions and comments. But if you don't want to do that, you could just come and see me.